Hi guys, today I am and team members are going to present our project which is solar power wallet sound system. Now I gonna introduce my member of groups. First of all is Efosina, secondly is Yap, thirdly it's me David, and lastly is Fikri. Before I present our project, I like to explain why we choose this project. Slow farming. Slow farming, where people build special houses to attract slows and collect their nets, is a popular business in Malaysia. It started after a tsunami in Indonesia sent many slows flying to Malaysia. Now there are over 22,000 slows houses from small ones to fancy ones. These houses have things slows need to feel safe and happy like sturdy wood for building nets, pools for bathing and good ventilation. They even have special sounds to lure slows in. Normally, the slows have electric connection by TNB supply and the electric bill will be high. We decided to do a project which can help to save electric bills. So we finally coming up with solar power wallet sound system. Now I like to explain solar power wallet sound system. Solar power is one of the extensive renewable energy available in our earth. Renewable energy from solar power is derived from the sun's rays which is extensible and connectively replaced it. Solar panels capture sunlight and convert into electricity through photovoltaic cells or concentrate the sun's heat to generate power. Now I like to explain definition and types of renewable energies. A solar panel is a device that converts sunlight to electricity. It's made up of a photovoltaic cells that capture photons from sunlight and electron movement that generate the flow of electricity. These panels are commonly used to harness solar energy for various applications from power homes and business to changing charging small devices or providing electricity in remote areas. And battery is a device that stores and delivers electricity energy through the chemical reaction. It's concern one or more cells that produce electron and creating electricity when connected in a circuit.
Third, we use LCLM317. LM317 is a voltage regulator integrated circuit that commonly used to produce a stable and adjustable output voltage. Next is a resistor. Resistor is an electronic component that limit the flow of electrical current in a circuit. And lastly is a LED and buzzer. So when the electrical pass through this device, it will active. Next, we go to the application circuit. We go to the circuit and calculation. Solar panel 9 volt, which is for solar power transform into the electricity energy to the circuit. Diode 1N4001 will connect it to the mitigate the risk of the reverse current flow. LM317 received input from the solar power. It was connected to the resistor made up of R2 and R3 in order to get the desired output. The ICLM317 output pin will register 7.5 volt because of feature of lead acid batteries. We are charging in a 6 volt battery with 7.5 volt. A volt 6 volt lead acid battery can only be fully charged with 7.3 volt. We have therefore selected R2 and R3 to provide 7.5 volt as output in the V put pin in consideration of the losses. A battery need to receive current equal to one-third of its AH rating. The purpose of the R4 resistor is to limit the input charging current to the battery, which should be used an input charging current of the 0.5 A signed with using a battery with 4.5 AH rating. Utilizing a 50 ohm R1 resistor, the current was limited.
Hello, my name is Susina. Today I would like to show our project, and this is our project. Our system will produce a sound from 7 a.m. until 6 p.m. Our project is powered by solar system. This is our solar panel. And this is where we put our switch button. This one is for lighting, this one is for buzzer. If we switch on the buzzer, it will produce a sound. This one is the light indicator, and this one is the LDR. When there is sunlight coming through the solar panel, the light indicator will light up, which show there is a power flow through the circuit. When there is no sunlight, the indicator will not light up. Let me show you. And here is LDR. The LDR react as sensor. When the LDR detect light, the buzzer will buzzing. If the LDR is not receiving any light, it will turn off. Let me show you. Besides of buzzer and light indicator, this circuit also consists of LED in front and both sides. These LED are used in night time. In real application, the LED are controlled by switch that help us to switch off, on and off the light. This light can be used for doing maintenance in the night time and see clearly what the problem and fix it. So, for example, during night time, there is no power coming through the LED. But within rechargeable battery, it will supply power to the LED. Let me show you how it's work. Sorry. We can imagine now it's night time. So when I switch on the switch, the LED will light up.
I will present our circuit that we have done. The apps that help us to construct our circuit is using Proteus. So as you can see in here, this is our circuit that we have done. So let us start our simulate. So when the simulation is start, the solar panel will absorb some light and convert to electric current. And then the current will flow across the diode. And then the diode will let the current flow in one direction only to protect solar panel by prevent the backflow of current. Then will continue to flow to the whole circuit. And when current flow in the rechargeable battery, the rechargeable battery will charge the current, and during the night time, the rechargeable battery can produce power to the use of buzzer and 3 LED lights. And then the advantage of choosing rechargeable battery instead of deposer, one is cost effective, and second one is the environmentally friendly option. So as you can see, when I turn on the switch, the current will flow to the 3 LED light, and the LED light will light up. And besides that, when during the night time, the LED also can still light due to the supply power from the rechargeable battery. And for the second switch, when I switch on, when I switch on the second switch, the current will cross the LDR sensor. And then the function of the LDR sensor is to detect and measure the intensity of the light. It works by changing its resistance based on the amount of light falling on it. So you can see when I increase the light detected by the LDR, the LDR sensor will detect, and when light intensity increase, the resistance of the LDR decrease, and vice versa. So at the morning, the LDR sensor will detect the light and let the buzzer buzz. When at night, the buzzer will stop buzz because due to the sensor detect light. So because of buzzer in this apps cannot be buzzed, so I change the buzzer to LED to show the working of the principal. So as you can see, when I turn off the light indicate the LDR cannot detect the light. When I turn on, the LDR detect the light will let the LED to lights up. So that's all from me. Thank you.